Looks like we're about 2 minutes in. I'm going to go ahead and get started. Hopefully, I'm seeing some chats come through the chat side of the application. So if y'all have anything you want to put through chat, just send that along, and I'll be glad to address any questions towards the end. So first things first, my name is Jake Necessary. I'm a principal cloud security consultant here at Cloudreach. And I'm based out of our Knoxville, Tennessee office, but I typically do work from home because I'm a few hours from there. So I wanted to go ahead and get started here with our agenda. So first things first, I'm going to talk a little bit about Cloudreach. Then we're going to move into the topic of building trust. That's just a general trust type of topic. After that, we're going to talk about trusting Google Cloud and why that's something we can do. And we want to talk about Beyond Corp, which is Google's Zero Trust implementation. And then we'll conclude out the presentation and take some questions. So a little bit about me. My name is Jake again. I live in Northeast Tennessee. I've been in IT for quite a while, from all kinds of different projects and that kind of thing. And ironically, I'm based out of a little town called Jonesboro. And I'm about 2 hours from our Knoxville office, which is quite interesting. I have been with Cloudreach just a brief time. I come from a history of cloud backgrounds and security. That's just a little bit about me. All right, so a little bit about Cloudreach. So Cloudreach is a Blackstone portfolio company. We have about 19 offices that are global. Obviously, we're a leader from 2017 through 2019 in the managed services realm. We were born in the cloud, and we have a unique software and product offering. We'll go into that in just a moment. We have, I believe, around 900 to 1,000 employees, over 800 cumulative certifications across our organization. And we've also been named Google Partner of the Year in Security the last 2 years running. So that's a pretty cool thing. Just moving forward. So this slide really represents kind of our buckets of services that Cloudreach provides. I actually am in the advisory bucket specifically as a consultant, but we perform advisory type functions, platform development, migration, transformation type activities, management through managed services, application development, and helping get data moved into the cloud through some data engineering activities. We do have a specific piece of software. We bought a company called Cloudimize, and that allows us to spin up this product in an environment, and it help us map that migration. So it's a pretty cool tool that will help us understand how to load up the cloud with workloads and that kind of thing. So the first thing I really want to talk about is building trust. Now, the presentation is broken into basically two more sections after this. This section is really driven by trusting the cloud. This is not marketing blab necessarily. This is really focused off of an academic paper that we can provide you guys with a link to. But this is what cloud customers think about trusting cloud partners. This is what the customers think, and this is through academic research. So I'll stop that paper a little later, but these are the items that people are concerned with. One is securing their data. Two is providing a quality of service type of activity. Next is a grade of service. And then validation of that activity through service level objectives and agreements. And I'm going to introduce at least a new acronym that I just learned called Trust as a Service. I don't think people have really worded it that way before. This paper obviously has done that. But what trust as a service is basically understanding a third party that validates others' trust. So, for example, PCI certifications, ISO 27001, those are all trust as a service type activities. So what we're seeing with cloud customers are that they're really focused on making sure that they have a level of trust with the partner. And it's going to be a little bit contradictory here in a moment as we talk about zero trust, but we'll get there. Let me move on a little bit. This paper that I'm talking about actually went through different factors influencing trust. And basically the things that we're focused on are where is the data located, what country, jurisdiction, that kind of thing. Understanding how to investigate the status of the data, to understand that visibility, data segregation. So cloud customers are focused on the concept of my data being separated from another person's data, especially in multi-tenant type of environments. The availability of data, access to data, identity, which we're going to talk about in a moment. Backup and recovery, not mentioned here, will be high availability and that kind of thing. Regulatory compliance are important factors that influence the trust level. And then finally, long-term viability. So making sure that trust is built through a long-term relationship with a cloud partner. We kind of do that through service level agreements and service level objectives, uptimes, those types of activities. So real quick, this is a really important slide. I know that there's wild different versions of this slide that float around here. This is an official Google slide about shared responsibility. But if you look at an Azure or AWS or any other type of shared responsibility model, generally this aligns the same. I've taken an interesting approach to the colors. There was some thought into the colors. So I feel like Cloudreach is a Google customer as well. So I used the customer color is more or less a Cloudreach color, kind of an orangish color that you see in our logo. And then the Google side of the house or the Google responsibilities appear in kind of a gray area. And I use that specifically because when we talk about building trust, the functions that the cloud provider performs a lot of times are in a vacuum to us, or in a box that we can't see into. And so part of this presentation is to understand how to shed some color into these gray boxes and how things are done. So as we look through kind of this RACI document, if you will, basically content is always the responsibility of a customer. Access policies are always the responsibility of a customer. But as you move into software as a service or into platform and infrastructure as a service, the responsibilities between the provider and the customer change a little bit. And it is absolutely possible to have multiple services with multiple levels. So maybe you're using Gmail, so that's software as a service, but the storage services, maybe it's infrastructure. So that's the way that this kind of works through these categories that you see over to the left. So the last section was about trust and responsibility. And then now let's move into a discussion around why you should trust Google Cloud. And so this section is made up of a lot of documentation around what Google is doing to earn trust. Now, as we move forward, we're going to talk about zero trust and what that means. I think that you should always be very skeptical of any partner or anyone, right? So the zero trust model that we're going to talk in depth about is a good model. I think that you need to validate trust or verify trust. So, with any relationship that you have to kind of work through that attitude of building trust with folks. And so the next few slides are going to really talk about how trust is built inside of Google Cloud. So this slide's a little different than the previous slides about what do customers want and what do they expect. There's kind of two different things potentially, but Google has built their cloud platform on some customer expectations. So for example, if you looked before, identity is across the board. So allowing access, when you look at all the different service offerings, identity is critical to allowing people to access the services that they want. So one of the important concepts of Google Cloud is the delivery of services ensure that people with the right identity, the correct identity, are able to access every time that they need for the right purposes. So that's really what the kind of the high level vision of this activity are. Prioritization and focus. If we look at around access and innovation and threats and risks, So Google has placed access and innovation ahead of threats and risks. So what that means is, as products are being innovated, we're building that security into the environment, reducing risk and threat. But we're really going to be focused on access ahead of a threat. So if we think something is a very, very focused threat, that's not going to be deployed. And that helps us really enable this division of responsibility and control. So here are some principles that Google has documented. So number one, we're wanting a defense in depth type of attitude. Our focus is to be at scale, and security is turned on by default. We're going to go into a little more detail around strong cryptographic identities, but another principle is to have strong identities. And maybe a horse I might hit a little hard today will be security provenance. So as we talk about how we build security into the environment from literally the chip all the way to the service. Also transparency. It's often termed access transparency, but I've kind of purposely cut the word access out of that discussion because I believe that things are super transparent in the systems that we have around how data and activities are accessed. And the ultimate goal is to reduce the unverifiable trust surface. So if we think back to that, to the picture with the orange bars and the gray bars, the trust surface in this case would be Google. So what we need to do is to add color to those gray bars. So how does Google handle certain activities around identity or encryption or all these kind of controls that we're always concerned with? We're trying to reduce that, reduce the amount of gray is what we're essentially doing in there. So the goal of this presentation, at least part of it, and also the goal of, I would think of selecting a cloud provider is to understand the grayness and shed some color to that. And that's really what I hope we're able to accomplish today. So identities is a kind of an interesting topic. I will say that there are multiple types of identities. And as we get to some more drawings later on, we'll kind of talk about how identity makes its way into the system. But it's more than just a user. So often we will label a user as the identity, but devices have identities, machines have identities, services, code, all have identities. And so when we say something is identity aware, it's more than just a user. We're really combining all those features to produce like a resulted identity whenever we're doing things. It'll come a little more clear later on in the presentation, but cryptographically secured identities occur through devices, through users, through machines, service, and code. So let's start really at purpose built. So if you read a lot of Google documentation, you're gonna see this concept of purpose built. But just, I mean, old school security says the first line of security is always physical. And when you think about a server, and it's obviously got components in it, the first step of security inside of a server, for example, would be the chips that are in it. And so what Google did was they built a purpose-built chip that's called Titan. You've probably heard of the Titan key, which is a two-factor type of key, but there is a chipset called Titan, and that's really the basis of all of these Google services. So for example, the whole data center is purpose-built for the function that it's going to be utilized. It's got networking stuff in it that is purpose-built specifically for networking and storage. Obviously, it has servers in it. And all those things kind of come back to the provenance of the Titan chip. That's where this all starts. And the important concept to understand is before you can trust a provider, you need to trust the computer that's in it. You need to trust the chips. And that's what we're doing here is we're establishing a hardware root of trust. So everything is banked on the security of that chip and it helps add value to the organization, what you're doing, because we're building that hardware root of trust right from the get-go. So it's almost like a physical activity, a physical control, and it helps you secure the environment. So some differentiators around Google. So I'm kind of repeating here, but purpose-built infrastructure that does design the end-to-end provenance. It's a security legacy, if you will, from the chipset. Things like hardware-based tamper protection, encrypted global network that's private. All those things are purpose-built inside the infrastructure bucket. As you look, security by default, and this is critical. Data at rest, data in flight are all encrypted. We'll talk a little more about that later. Distributed denial service attacks, we're protected against that activity. So really, there's no downtime because of availability, those types of things. Real transparency. I know the focus has always been about understanding how do Googlers support the environment. How are they walking into the data center? How are they logging into systems to support them? And this should be a question that you ask any provider, perhaps even on-site providers that are performing support, other cloud providers. Understanding that transparency around how people are accessing the environment is super critical. And so what Google has done is they have made that transparent through some control panels, and I'll show you that in just a moment. But that really establishes that level of transparency. So to kind of wrap out this slide, proprietary control. So things like Gmail phishing and email protection, if you're a Gmail SaaS type of customer, is obviously a critical thing. VPC controls, the Cloud Security Command Center is kind of the panel that I was referencing around real transparency, but ultimately gives you a one pane of glass. User protective services. All these things are things that differentiate Google Cloud security from other clouds. And so understanding a lot of these high-level activities, but specifically maybe the tools that are used, again, adds color to those gray bars. Okay, visibility and control. So visibility and control is an important concept of kind of validating the trust of a cloud provider or any provider. So having the visibility kind of begins at the Cloud Security Command Center. So inside of this one pane of glass, you're able to review all kinds of pertinent information. Specifically, you're able to kind of understand who's been accessing the environment and why with some details. So for example, if you open a ticket, it's serviced. That data, as people, if they've had to access the information, will be put into that environment. It kind of takes me back to the old e-discovery days in email platforms. You obviously have metadata around an email, but you also have content of an email. So as we think about visibility, it's understanding, who can actually read the data and who can read the metadata. It's kind of the same concept. This is validating to us who has seen what in the environment. As we move into understanding data and classification, so data classification is kind of dear to my heart. I know there are many organizations that actually, this is almost a Chevy Ford battle, where data classification policies don't exist at all, or they're loose, or they're non-existent. But it's very hard to protect data with the right level of controls if you don't classify it. And I believe, kind of at a core concept, that data should be classified by the data owner, so they should understand that. But as we move into the visibility and control portion of this, if you know that data is PII or PCI or company confidential or whatever classification your policy describes, that helps you protect it. And as we grant access to the data through applications and specifically to users' devices, code, all the things that we talked about in identity, it's super important to classify that data, because now all of a sudden you may be able to limit exposure on the data. So it's important to have, in my opinion, a data classification policy. And as you move into the cloud, this will help you formulate those strict access controls. Again, another point on access transparency. So straight up, the access to data centers at Google follow the same physical controls that you'll see at many. I mean, it's like breaking into Fort Knox from a physical perspective. So there's obviously very limited data center access. Understanding why customer data is accessed is super important. So that, again, this provides that access transparency. And in some cases, there may be data that you don't want Googlers to be able to read or see or utilize. So there is a process of access approvals now, which allows you to kind of subvent that activity. So one thing I'll say is, and this is somewhat of a marketing looking slide, but it is a reality. So in order to have a trusted infrastructure, you really have to understand how each layer works. And so, for example, operational and security, this particular level. So Google does run a 365/7/24 type of attitude. The data that comes into the environment is looked at. There's a threat, and there's basically a SOC that's running to protect that operational and device security. And as we, as consumers of the environment, build out rules around access policies, then that helps us protect the data even further. Internet communication. So, data in flight is encrypted. Data at rest is encrypted as well. As we talk about communication, there are private networks that connect nodes, that kind of thing. So it's important to trust that the cabling that connects all this stuff together out to the internet is a secured activity. And, by default, data in flight and at rest are secured in the environment. But there are other controls that are being leveraged to ensure that there are private communication channels occurring. I think I'll probably beat the dead horse about identity, but I'll say it again. Having multiple layers of identity and then really building into identity the rules that you want to access, then it really changes. I mean, we think about the old days. We would have an environment at our corporate headquarters, and we would align these, and I'm sure this analogy has been beat to death, but it is really a perfect analogy. It's like our castle, and we have a moat around it and a drawbridge. And as people attempt to access everything in the castle city, they can't get in, right? And so that's the old school way of doing networks, right? The moat was the firewall, and I guess the drawbridge was maybe a web application firewall, and that really kept people from coming in. The problem today is we don't live in a castle anymore. Our world extends everywhere. It's infinite. And what that means for us is we have to protect things with firewalls, for example, but we have to really focus on allowing identity aware activities to going on. So that's one of the advantages here. As people log on, they go through an access proxy that really identifies where they're at. It scores them, and then it allows them to have access based off of the rules engine that we define. As we talk about storage services, again, encryption at rest is pretty cool. Encryption at rest. Let's allow the scope of this topic, but the way Google does storage services is great. I think service deployment, so and hardware infrastructure are all multi-layered, multi-tiered activity. Hardware infrastructure is purpose-built chips, servers, so the hardware, the physical activity around the data is well supported. Also, from a service deployment, as we build services and roll those out, we're able to secure those as well because of the security by default attitude. So this is a really great slide. I love this slide. I can't take credit for this one. This is one that was already in existence. But when we talk about the security program activities, and you'll see there's a couple similar slides. This one talks about activities. But if you focus yourself on the center of this presentation, you will see that from the building up, we've got things like infrastructure, data, and application security. So, you know, from the infrastructure level all the way to the application level, security is something that we're focused on, right? We're hardening the operating systems. We're hardening the configuration management through patching and vulnerability management. We're able to identify issues with the hardening side of things, also issue with configurations, and fight maybe vulnerabilities that perhaps we need to have additional controls on top of. Policy enforcement, the ability to kind of control the devices that we have. And again, devices do have an identity. So as they come on board, however they're labeled, helps us really define if they can get to certain resources. Same kind of attitude with networking. As we define the network security, enforce a perimeter, again, kind of the perimeter around the data that we're presenting, but also noticing that perimeter is identity access aware or identity aware context, and allows us to segment our data in the types of buckets that we need to achieve compliance and also to achieve a better security posture, managing that remote access, denial of service defense, that kind of thing. And then as we move into the data layer, you know, we're able to understand where our sensitive data lives. We're also able to classify that data and enforce controls around that activity, and simply prevent the exfiltration or loss of data. I mean, that's going to be the first question in the case of a data breach, on-prem, off-prem. The first question that Google or MasterCard say in a PCI environment is going to ask is what data was exfiltrated. And you're going to have to figure that out. And I think the first thing that we can do is establish a good data classification policy and lock down data that we don't want to be exfiltrated. As we talk about application scanning and application security, the ability to test applications against, say, OWASP top 10 to make sure that we have built in the right security and activity. Additionally, API security around that. If you think about it, again, we're labeling code as an identity, so it gives us some flexibility as we move forward, and we're taking code and services and providing them out to people based off their identity. So we've got a strong level of application security. So all this kind of works its way up to identity and endpoint. So as you can see, kind of from the center, we've got identity and access management versus endpoint security. You know, I think a lot of us think strongly towards the identity and access side, but oftentimes, more than not, endpoint security is somewhat forgotten. I think, you know, as we go through this, I'm going to put an emphasis on endpoint security, and we'll see where this lands. Now, on kind of the wings of this slide, you've got governance and risk compliance way over on the left, and then way on the right, we have security monitoring and operations. So I think earlier in the slides, I showed you all the trust according to an academic paper. Again, that paper is pretty interesting because they take a quantitative risk analysis and security and threat and privacy analysis approach to data. And so it is quantitative versus typically a qualitative type of activity. But through the governance, risk, and compliance programs, we must understand our risk and define and enforce policies that help us reach that. I'm using the word certification here in kind of a broad perspective, but there are obviously attestations, certifications, compliance measures that exist. You want to make sure that the environment your data and people and services live in hit the certification pass, and then demonstrate compliance. And I'll just take just a moment to kind of jump off topic for 1 second and say that a lot of times organizations build their security program off of a compliance standard. And I would highly caution against that, because I believe that your security program should be your blueprint on how you act. When you talk about building towards PCI compliance, if someone later asks you to reach another level of compliance, you've only built the minimum controls into an environment. So it's important that you're compliant, but I think it's even more important that you build a strong security program, and compliance should really present itself as an output of your security program. So for example, if you're PCI aware, Google's PCI certified as a cloud provider, your processes might be PCI certified as a service provider for yourself, for example. But it's important that you build in more than the minimum requirements for a compliance standard. And so that's where Google comes in, kind of the top. You'll see a little later, I've got a compliance slide, but it's very important to know that there are multiple levels of compliance, and you should potentially build your security program based off of a customized. So say your Acme company, if you're Acme company, you should probably build Acme security policy and write your own controls. They might be heavily influenced by these compliance standards, but that will allow you to have controls that you're aiming for, and then treat the compliance requirements that you have as modules that you strap on top of your program. So I know it's a little bit of a segue, but I believe pretty heavily in that. And so something as we kind of look to the far right on security monitoring and operations, again, you want to be able to respond to an incident. I mean, the reality is this: in the cloud, you're going to get attacked, right? So you need to be able to detect those. You need to be able to respond to those. You need to be able to make sure you've got the right prevention mechanisms in place. Essentially, if you're plugged into the internet somewhere, you're going to be under attack. So the goal here is to arm this whole, and kind of wrapping this whole slide together, all the activities that exist out there really go to putting more armor on you as an organization. As we move into specific controls, I'm going to kind of go through here really quick. It's really the same slide. It's just how are we executing those activities. So for example, cloud infrastructure, things like encryption in flight or in transit, encryption at rest at the storage layer, cloud armor, inside of data security, the ability to do data classification, again, the ability to have your own keys if you choose to from a security perspective, scanning, setting up device management from an endpoint security. It all kind of goes back to that Titan chipset, if you will, on that infrastructure security. But as we look at access management, if you are using two-factor, for example, which another sidebar, everybody should be using multi-factor all the time. If you're not, I highly suggest that you do. And there are ways to enforce that. There are also ways of saying, hey, if a computer that we manage comes from our network Monday through Friday on these time areas, and it's already a trusted source, maybe they don't have a two-factor that time, right? So there's a way to put logic into how you enforce two-factor. Then there's the other side of the house where CISOs want to enforce two-factor all the time in every situation. So it's kind of a play on user versus that, but there should be some play of two-factor for sure. I come from the camp of enforcing two-factor more often than not, but somewhat of a Chevy Ford battle, depending on who you talk to. As we talk about risk, third-party audits and certifications, critical, just because as we look at, say, Google, for example, the third-party audits and certifications that they've achieved, Google can say, I'm secure, and you can trust and believe them, and I do, especially after seeing how they encrypt data at rest, but that's another story. But it's important to know that the United States government has issued Google with certifications around FedRAMP, around NIST 800-53, 171, all those areas. It's important to note that the European Union has certified them. Those types of things. I'll have a slide where I've kind of got a splotching of certifications, but I'll talk through that. And then over on the monitoring side, there are things like Forrester. We're giving that access, transparency. There's security centers, command control centers, things that we look at that really give us that monitoring and security ability to reduce threats, to identify risks, those types of things. This is a great type of tool. So I guess the question always comes up: why Google Cloud for security? there are multiple answers to this, I think. So, but there are two core concepts. So, Google has the idea that the data is yours, and I absolutely agree. And I think that as we look through what Google does for us, Google never sells data to third party. They do not use customer data for advertising purposes. By default, data is at rest and encrypted very well. It's encrypted well at rest and in transit. So, access to data, if you're an old school security guy or gal, the CIA triad, if you will, confidentiality, integrity, availability. So, as we look at data, we want to make sure that you control who can read data or the confidentiality of it, and who can alter data or the integrity of it. And that's super important. And it's comforting to know that contractually and through Google's security offerings that we own our data, and that data is protected. Also, Google guards against insider access. There's really no backdoor access. So there's a very documented privacy practice in existence. But as we look at how our users consume the services as IT folks that we provide them, it's really good to understand how we can guard against access to data that isn't warranted. As an old submarine guy, we always wanted to have a need to know and a security clearance, and to do things that we did on a submarine. I probably didn't tell you in the brief, I'm an old submarine guy, but as we look at that idea, that two-factor, the two-factor or the two-person integrity model is not new. And so as we guard against access to data, we need to make sure that people have a need to get to the data, and that they have a means, and that they're approved for that data. And that's what this guard insider access means. It's why I think Google has a great security package. I want to move on. This is the slide. I wanted to show you this slide. I put this together from Google's website. I pulled the little images from there and that kind of thing. So there are 53 of them. There are only 23 of them shown on the screen, because I figured I wouldn't kill you with a big blotchy slide, but I ended up doing that anyway with all these boxes. But what I wanted to say is that don't just take Google's word for are they trustworthy, and don't take my word. You have to build that trust yourself. But hopefully through these slides, I've shown some good data that helps you come to that conclusion. But here are some third parties that say they're secured. ISO 27001, ISO 2717, you can kind of see those. CCPA, which I'm not sure if you guys are familiar with California Consumer Protection Act, but CCPA is deep to my heart just because of the requirements it places on IT folks. But if you are doing business in California, or you have California employees, CCPA is applicable, so you should check into that deeply. It is in effect already, and they do redefine a lot of key things, like IP address is considered private data now, where maybe other models didn't consider it privacy. So there's a lot of key things there that folks should look at. Cloud Security Alliance is an organization that provides great tools that hopefully you guys have looked at before. If not, you should check them out. They've stamped their approval. As we kind of fly through some of these, GDPR is approved. I know we've all been taunting GDPR. GDPR, by the way, CCPA is California's more strict version of GDPR. There are, I think, 32 copycat CCPA laws that are currently being talked about in other states. So everyone needs to get their arm around those privacy rules. This FR slide, by the way, that's FedRAMP. That's their little symbol. FERPA for education, and HECVAC for education. HIPAA for healthcare data. PCI, all the NIST worlds, SSA 18, SOC 1, 2, and 3. You see all these on here. This slide really represents the majority of the U.S. certifications, a few of the global ones, and then that last bucket is 28 more. That would be each country and kind of locality has their own list of certifications that may be on here. long story short, there's a whole bunch of people that have validated, certified, and accredited, and Google is accredited that they have a trust as a service type of environment. Now, all these organizations, I would call them trusted service providers as far as what they're doing, but everyone has pretty much stamped their approval on this. So we're going to jump into Beyond Corp real quick and Zero Trust. I will say, I guess the analogy is that I'll use here around Zero Trust. When we were the parents of younger children and they wanted to spend the night with a friend, we would always make sure their parents passed our parenting check. I know it sounds kind of crazy, but we zero trusted every parent. Just because the kid's good or bad doesn't mean the parent's good or bad. So before we let them go and spend the night with someone, we had zero trust, quite frankly. And so Zero Trust is the industry buzzword, and Beyond Corp is the implementation of that Google has went through and what we're talking about for the rest of this presentation. So I don't know if you guys are one of those Zero Trust parents, but we were probably overly protective, I guess. But as we move forward here, so and as I alluded to with the castle model, traditional perimeter models do a good job in protecting your environment, right? But the deal is we don't have four walls anymore. And so we have to make sure that the services that we offer are encompassed by almost a rubber band. And as we add more services, we just make the rubber band bigger and encompass it. So that perimeter is not strict, it's flexible. And as a result, you need to implement, additional controls. So why do we implement? So it absolutely improves productivity. If you think about it, your employees, especially with COVID-19, can work from home and access work resources, but do it through a secure manner. VPN of the old days of loading the VPN client and the cert and all that mess was just an IT nightmare. And so by having things that are independent identity aware, then we're able to really able to raise security posture because we can take those items and make them available in an easy format, but still not compromise our security. So beyond lessons learned. So the reality is Beyond Corp started as a Google's own implementation of Zero Trust in their own environment. And they've learned a lot of things. So for example, you need executive support to make this thing work. So if you're just sticking a few developer resources in the cloud, but you're keeping all the homegrown items at home, you really should have a conversation on how can we improve our security posture by moving it to the cloud? And there is a lens you can look through to really provide that, because I inherently believe that cloud infrastructures are more secure than on-prem. I'll say that and say that keeping in mind that content, as we looked at before, and access policies are always the responsibility of people. But I think cloud providers bring a breadth of tools that help you do that. I'll say a real quick thing around appointing change champions. So there's this concept in organizational change called a shared diagnosis. And what shared diagnosis, this is more academic, but shared diagnosis, what it means is that everyone has to come to the conclusion, and when I say everyone, from the bottom to the top of the organizational chart, needs to understand if something is true or not before they'll really commit to it. And moving to the cloud may have people that are camps of getting there that are frustrated, that don't want to do that. There are people that may want to. So when you're implementing a change like that, it's imperative to come up with a shared diagnosis and explain, communicate clearly why you're moving to the cloud, what the advantages are, and that will help open up the lines of communication around. There's still some bumpy roads when you make any kind of change. That's why you need change champions, people in the organization that will help a change pilot or a group of an application make its way to the cloud and spread the idea that the shared diagnosis is true. So when you look at organizational change, so things like moving to the cloud, it's important to understand that shared diagnosis. I'm going to speed up here a little bit because we're running out of time. But as we look for the vision as we look at things. So we want to understand the policies around how we implement our zero trust environment. So access policies, the reasons are critical, that in every model, that's the responsibility of the customer. So of Cloudreach, of you as we're customers and consumers of Google Cloud. Understanding attributes. So I'll kind of beat the dead horse here around the context of the user, their device information, that type of stuff. And then ultimately to protect all applications everywhere. This is my beat the devices in the ground slide, but I'll just say that devices do have an identity. That's critical to know. They also receive secure default settings. You set those. Again, I liken it almost to riding in the car in a carpool with someone you don't know, but you're in a carpool with them, and they're a bad actor. You're in the car. It doesn't necessarily mean you're there. So you have to understand who's driving, that kind of thing. So it's not that users are distrusted. It's that, and they may be, but it means that as people access the environment, you don't know what you don't know that could hurt you. So that's why you need to produce standardized configurations, push security configurations, those types of things. But you also need to test those rollouts and phase things. So as we look at managing devices, they have an identity, they have secure defaults, also dependent on the quality of the device data. So that's really important too. So we have to trust the information that we have around our devices. So as you move to the cloud, for example, the devices that make their way there or are operating in that environment, we need to make sure that we understand that information clearly so we can apply device activities. And then, so as I kind of move to this slide really quick, I'm just going to hit it at a high level. There is a device inventory service that exists inside of Google Cloud, and you can see that everything kind of reports to the inventory. But in order to protect your environment, you have to understand your assets. You have to understand their vulnerabilities, how they're arranged in the directory, how they're networked. Do they have certs installed? How are they managed? How are they patched? All that reports into this kind of centralized database, and that's critical in applying what you're doing. Also critical, and I think everyone's kind of got this story, is securely identify the user as they access your environments. So there's a database that exists, and obviously it gets feeds from, say, Active Directory or Google directories or whatever directory kind of thing, but that we can track the identity of someone, their groups they're in, what their jobs are, what their status is, and we can enforce that with primary and secondary credentials. So you have things like username, password, and a FIDO key. The other thing is, as people access what you've positioned to them in the cloud, it's imperative that they have a short-lived session. So, in the old school world, you just log in, and as long as you were there, you had access. I mean, short-lived sessions re-authenticate. They limit the exposure that device, that identity, that code, all those identities we talked about have access. This is a monstrosity of a diagram, so I'm just going to kind of talk through it quickly. We have devices, we have people, we have single sign-on, all the kind of the arrows that you see. And if you try to follow the arrows, sometimes they don't even make sense in this drawing, but you can see that everything centrally points to the access proxy. And that's an important concept. As people enter the environment, they're presented in a certain way. And so when I say they, I mean their device and them kind of merge together as one activity. So I'll move to this really quick. This is really the high-level architecture for Beyond Corp. So again, devices trust a device's an identity, and so is a user. The device's posture and the user's behavior are also attributes of them. So this is kind of the way that we, far right here, we've got apps and data that people can access. The far left, we have things that are heading that way. And so if you look, an analogy would be a user logs on from a third-party country that they never log on from, right? So you may want to enforce two-factor. You may not want to allow access at all because you don't do business in some country that's out there. You know, and so that's important. The device may be managed or unmanaged. If someone connects with an unmanaged device, you may want to enforce two-factor. You may want to not allow access. Things like the time of day, the session age, all these things kind of go together that hits this rules engine that you see in green in the center. And that really positions you to get an enforcement. So we get to write a rule that says, if you want to access gadget application, you've got to be coming from a trusted device from one of our locations using two-factor on a managed computer. And that might be your rule. You might say everybody can access our public website, no matter what device they come from. You may want to, so you kind of get the idea that, and why user trust and device trust are so important, and kind of why I talked about them so much. As users and devices come in, they form a picture that gets presented to that rules engine, and then it's enforced at the enforcement point. One thing I'll say is this is a case study that's found on Google's website for the New York City Cyber Command. Now, they are leveraging Google services, and they've implemented a Beyond Corp type of attitude in a zero trust environment. And that really allows their folks to access what they need securely, but also kind of easily. And usually you don't see security and easy in the same sentence, because typically as you enforce controls, you know, the easy kind of goes away and it makes things more complicated. But by building our systems with identity aware activities, device, all the things we talked about, service code, then it allows us to ease the burden on the user, but not give up the security stance that we want. So, and this kind of in summary, Beyond Corp and the ability for remote access, essentially, or anywhere access, I would rather use. This type of technology lets you present securely applications to your teams in a secure way. And so this, you know, as we summarize here, this really reduces the cost of activity and increases your security posture, and it helps you really kind of reach that level. So we're just about out of time here. I would like to maybe take a few questions if people can put them in the chat area. And let's see, I'll go ahead and get through the couple of slides here while they're plopping through. But I do want to thank everyone for attending. Hopefully this gave you some insight on a few things. And so I'll just encourage you there. Let's take a look at a few of these questions here. So somebody asked, how do you implement compliance in Google into your compliance strategy? So I'll just say that, just generally talking, I recommend that you have a information security policy that maps to multiple compliance standards, and Google just becomes another module, if you will. And in a lot of cases, they're going to answer like PCI questions. If you're using, let's say you're using SQL as a service or Cloud SQL inside of Google, then that service is already covered under the PCI brand of the certification that Google has. So that means you don't have to necessarily dive into the servers that do that. You just have to produce that type of activity. So Google is an augmenter of compliance because they've already done much of the groundwork. So the more things you can push towards services really helps you meet that compliance standard. I've also been asked how you reduce that, how do you reduce the concerns about maybe trusting Google, that kind of thing, reducing the unverifiable trust service. How do you do this? So again, security provenance, any one of these things you're implementing, you need to look at the security and how it's built. Again, Google has hardware-based root of trust. I introduced trust as a service as probably a new concept, but honestly, it was kind of a new way of forming it that I found from that academic paper. But what it means is, what third parties have already certified them, and do I trust them? So it's kind of that circle of trust, hardware of trust, trust as a service attitude. Let me look at some of these other questions. Encryption. So someone asked about encryption. Let's just say this: Google encrypts data in flight and at rest. But the way they encrypt data at rest I thought was very interesting when I read some articles on it and have seen it implemented. So what happens is the data is formulated in chunks, and this is kind of hillbilly talk, I guess, for me, but chunks of data, and each chunk of data is encrypted with a key. And so, you know, if you take a pie, for example, one piece is encrypted with one key, another piece of the pie is with the other key, and then at the end, the storage device itself encrypts at the storage layer. So it's like putting a pie in a pie pan. So it's encrypted by the pan, but even if you open the thing open, you can't tell if it's a blueberry pie or a strawberry or multiple berry pie by looking at it, and because each of those chunks or each of those pie slices are actually encrypted. So I thought that was kind of an interesting way of doing this. I know we're kind of wrapping up the session. Let me see if we got any more. I think somebody did ask about, I must have been earlier in the discussion, about the devices and how much emphasis I put on devices. Again, I put emphasis on devices because I think that is probably the one weak link in the chain. We are all really focused on producing good identities and hopefully two-factor or multi-factor, but often we forget about the devices in our story. And so I believe that's important is to do that. So it looks like we got about a minute left. I think I'm going to go ahead and wrap up this session. I wanted to thank everybody for attending. I'm super excited about the products and services and the way Google approaches security, and hopefully it showed in the presentation. And you can always reach out to Cloudreach if you have any questions. We have a cybersecurity accelerator service that you'll be linked to as an attendee, that kind of thing. If you need anything from me, I'm here to help. And again, I'm part of the advisory services at Cloudreach. I hope everyone stays safe amongst this pandemic. And so have a great day.